Physics is the branch of science that deals with the study of natural phenomena in terms of basic laws and physical quantities. The word physics is derived from the Greek word physis, which means nature or the part of nature or environment. The scope of physics can be divided into two major domains, such as macroscopic domain and microscopic domain. The macroscopic domain deals with the phenomenon at laboratory, realistic, terrestrial, and astronomical scale, whereas microscopic domain deals with the phenomenon in molecular, atomic, and nuclear scale phenomena. In the study of physics, when we look at macroscopic phenomena under classical physics, that includes mechanics, electrodynamics, optics, and thermodynamics. In physics, we attempt to explain various physical phenomena in terms of few concepts and laws. We see the physical world as the manifestation of some universal laws in different domains and with required conditions applicable as per the context. For example, the law of gravitation, which describes the motion of an apple which eventually falls to the earth. It is also explain the nature of force between earth and the moon. And also the force that bound the planet in the solar system in their orbits and keep them in motion in their paths. Thus, we derive the properties of bigger or more complex system from the properties or a direction of simpler paths or constituents of the system. This approach is called reductionism. Physics is closely connected to technology and society. Most of the modern technology are the contribution of physics. Here are some of such technologies. These contributions came from all over the world. Here are the list of some notable physicists. These contributions came through observation, experimentation, or analysis of natural phenomena and the rules or laws that govern such phenomena. These came as the knowledge of fundamental forces in nature in physical laws. There are four fundamental forces in nature. All other forces are known as derived forces. The fundamental forces are: first one, the gravitational force; second one, electromagnetic force; third one, weak nuclear force; fourth one, strong nuclear force. First of all, we are going to discuss about gravitational force. It is the force of mutual attraction between any two objects by virtue of their masses. It is a universal force, means all objects in the universe exerts gravitational force on each other. We can able to walk or stand only due to the gravitational force exerted on us by the earth. It is a long range force. Second one, electromagnetic force. It is the force between two charged particles. Like charged particles will repel and unlike charged particles will attract each other. Charges in motion produce magnetic effects, and so moving charges experience a force in magnetic field. Magnetic and electric forces together called electromagnetic force. Just similar to gravitational force, electromagnetic force is also long-range force. The gravitational force dominates all terrestrial phenomena. We know that an atom consists of electron, proton and neutron. Inside the nucleus we can see neutron and proton. The neutron and proton binds a strong force between them, which is known as strong nuclear force. Next, we are going to discuss about weak nuclear force. It appears in certain nuclear processes such as beta decay of nucleus. In a beta decay, nucleus emits an electron and uncharged particles which is called antineutrino. Here the table represents the fundamental forces in nature and their relative strength, range, etc. So that we can say that the physical laws is nothing but the scientific generalizations based on physics observations and experiments are presented as laws or empirical relationships in the form of mathematical equations. Most of these laws are based some special quantities that remain unchanged in a process, which are known as conserved quantities. Laws based on conserved quantities are laws of conservation of mass, energy, linear momentum, angular momentum, charge, parity, etc.